All right, hello. Well, I'm Matias. I am a graphic designer and a developer. I work at Basement Studio as a development lead. And at the studio, we do use React to create websites for the brands that we work with. And sometimes, maybe in order to tell a story or maybe to add a little bit of magic to a site, we do use 3JS, which is a library to create 3D graphics on the web with WebGL. And when you use React and you start using 3JS, you start hearing about a library called react-midi-fiber. I don't know how many people here has heard about that library before. A couple, maybe. All right. So that library is a React renderer for 3JS. And what that means is that usually, let's imagine I just want to add a little cube to a 3D world. So I usually first to define its shape. So I'm going to create a box geometry. And then I need to define how it will look. So I'm going to create a material. And then we join those two things together in what's called a mesh. Don't worry if you don't know 3JS. That's out of scope. And finally, once we add that to the scene, we have a little cube. But then with react-midi-fiber, the code gets much more simpler. I just add a JSX element that says, hey, let's add a mesh to the scene. And inside, we put the box geometry. So 3JS knows that since it's a child, it should append it to the mesh. And all of the complexity, most of the complexity goes away. But most importantly, we unlock all of the power of React. So we can start using states and context. And it gets easier. And the thing that I always wondered was how how was that created? Because that's not React DOM, and that's not done by this library is not created by the React team. So how can this open source community create this renderer? And the answer is, of course, React Reconcilier. So this library enables us to create custom renderers for React. And that's what I'm going to talk about today. How can we create custom renderers? And when I was starting playing with this thing, I got invited to this conference. So we were like, OK, let's create a bunch of renderers and show them today. How hard can that be, right? And so I invite you to join me into the rabbit hole that has been the past 4 months trying to figure out how it works. But before we start seeing examples and everything, and I know this is the last talk, and we're all thinking about the wine that we're going to be drinking in a couple of minutes. But I ask you to hold on and just for a couple more slides, because we're going to see how can we create a custom renderer for React. We're going to create React Pizza Fiber just to simplify the example as much as we can. Let's first imagine how would this renderer even look like on JSX. So maybe we have a pizza element type, and then we have the ingredients inside. That's it. Is there water here? Yeah. Thanks. And OK, now that we thought how our renderer could look like, how does actually React Reconcilier works? And the way it works is that we grab the reconcilier from the library, and we have to pass in a configuration object. That's it. And this object is going to contain callbacks. So every time something happens on that JSX tree, the reconcilier is going to execute any of those callbacks. So for example, the renderer is going to say, hey, I detected that there is a new pizza element and also a pepperoni one and cheese. So it's going to run create instance 3 times. First, it's going to provide with the tag pizza and the props, in this case, slices. And then for the pepperoni, it's going to do the same. And except for the cheese, sorry, again. And we have to return an object that's gonna match the element that we are creating. In the case of React DOM, that would be like an HTML element. Like if we create a button, it will create an HTML element button and just return it. In our case, it will be either a pizza instance or pepperoni or whatever. And then the renderer says, hey, OK, the pepperoni and cheese are inside of the pizza, so I'm going to run the append child function. And in this case, the parent's going to be the pizza instance, and the childs are going to be pepperoni and cheese. And like we can do whatever we want with that. If we are creating, again, React DOM, we're going to like append the HTML elements and start building a tree. But if we're creating like a different kind of renderer, that will be very different for our case. Let's imagine like these are our classes for like creating pizza instances. Like we already have our library created for creating like a new pizza and ingredients. So our render implementation could actually look like this. We can switch on the type. And in case we detect that the type is pizza, we're going to create a new pizza instance and return it. Otherwise, I'm going to assume it's just an ingredient. And then append child is going to grab the parent and say, hey, add to the ingredients the corresponding ingredient. There is another concept that I struggle with. Like there are instances, which are like the elements on the JSS tree, and there are containers. And containers is basically, do you remember like when you create a simple React app, you need to like grab an element, and our entire application is gonna be inside of that element? Well, that's a container, like where our application is gonna be living into. Like it has to be like an object or an HTML element or whatever we want. So in the case of our custom renderer, it's going to be a pizzeria. I guess that's the next logical step. So we're going to create our container, and then we're going to say to the renderer, hey, let's actually create a root using the create container function. So those two things are more or less equivalent in React DOM and our React Pizza Fiber. And they want to say, hey, let's grab our entire app and render it in this root that we created with our custom renderer. So that is more or less how you create a renderer. There are, of course, like custom methods that we need to provide for the container. Again, to like add or remove childs to it. And there are other type of configuration. For example, if you want to support hydration or persistence, we need to like start adding more and more configurations. I didn't get that far, so we're stopping here. So now the hard part is over. Let's actually see something hopefully working. And to create all of these experiments, I had two rules. The first one is they don't really have to be useful, because when I learn something new, I mean, we are already getting paid to do useful things 8 hours a day. So if I'm learning something new, I won't aim to do like the next React 3 Fiber. Like just try to create something that's fun. And again, of course, it's not going to be production ready the first 10 times you do it. You're just learning. So with that in mind, the first render of the evening is react-midi-fiber. And it's basically using this library called chimp, which is a really useful library to like compose images. So the objective with this renderer is to build like a kind of Photoshop, quote unquote, where you can like paste different images together and like render a final image. So there are two element types in this renderer. One is GIMP figure to like actually load images, and the other one is group to like being able to move around things together. So if I update like a position of the spaceship and then I build again, right, it moves. This renderer is the first one. Please don't actually look at the code. And it only renders once. It doesn't support mutations. It's pretty simple, and it renders into an image. The output is just a PNG. Ooh, here, okay. Next up, I always wanted to create like games that can run inside of a terminal. So since I have already something that can compose images, like we can just grab those images and transform them into ASCII characters and just console log them. And with that, we can have React ASCII. This time, I actually enable mutations and detected like a lot of bugs in my code. But it works a little bit better. So if we run it, all right, it loads like a car image, and then it displays, and the container is like it's like a custom renderer actually here that just logs things into the terminal. And I can move around, like I can move around props, and in this case, yeah, it rebuilds. But this is not actually like reacting to anything. So let's move on this logic here and actually make it move. And I think I need to rebuild. Oh, and I need to actually like put the prop so that it re-renders correctly. All right, it's moving. Yeah. All right, so this one actually like reacts to props and can like change things around. But the organizers told me like, hey, we are flying you like 12 hours. Show something more interesting. So let's actually. And now I actually wanted to like create something that you can play on the terminal, because now that we have mutations, we can add hooks and like react to inputs, so we can actually build something more interesting. So I deployed a little game called MPX space faders like CLI. Ooh, typo here, typo there. Do not write just do never run Space Invaders. That's another library. I don't know what it does. And if we wait, ooh, oh, let's just MPX space. Yeah. All right. All right. Oh, now, and this actually like reacts to user input and has like custom components for collision detection and like actually working. That was the worst game I've ever played. Let's run it again and try to actually play something. All right. So you can actually sort of win or lose. And again, like since we are, I know what you're. It's actually. I know what you're all thinking. Can you run Doom on these things? And of course you can. So if I go up and then cd CLI Doom, I guess, yeah. So it will take a couple seconds to load. Of course, it's not that fast. And it is the worst resolution Doom you've ever played, but it is technically possible to play. So you can actually. All right. Next up, let's move away from just compositing image. Let's try something different. And I was reading and I heard about this MIDI type of file, which is a file for like describing music. So you can like store all of the notes there, and then you can play that music. And I had a problem here. I wrote the renderer, but then I realized that I don't know how to actually compose music, so I had to ask Cursor to do that. And it just, after a couple of iterations, we managed to get this. So if someone actually knows how to compute music, please reach out. Moving on. At this point, I was a little bit more confident, so it's like, okay, let's create like, try to create a most useful render, breaking one of the rules. And JSCAD is a library to like design 3D objects using like CAD types of files. So you get like different Boolean operations, and you can like create objects with it. So this one, for example, here, we have two spheres, and they are like with the union operation. That's not that interesting, but we can maybe subtract one from the other. So subtract, right? And like we can like start doing operations and start designing 3D objects with it. I think interception is another one. Intersect. Right, so now it's just intercepting the two spheres, and that's what's going to be on the screen. And by this point, I was like, OK, the React renderer really enables us whatever we want to do with the JSX that we are creating. So I wanted to try creating a renderer that can accept any JSX that we want to throw at it, mainly because I was tired of creating types. So this render accepts any component tree that just you throw at it. And what it will do is basically store all of that into a JSON file and tell DALL-E, hey, interpret this as an image, like try to interpret the structure of the components and try to create an image with it. So we can change this to, I don't know, night and save. And it's going to take a couple of seconds because the API is a little bit slow. But let's add night and then CT. So is it working? Yeah, OK, like, it changed to night. And a city should appear, yeah, there. So it will interpret any JSX that just you want to throw. And this one is quite simple. It just grabs all of the tree and like store all of your tree into a JSON and just say, hey, DALL-E, render that into an image. And well, that is the last render for the evening. All of the source code is on that link, and I'm going to upload the presentation there probably too. And yeah, if you want to reach out and actually implement one of these renders a little bit better, reach me out at Twitter or at the PR on GitHub. I don't know. So thank you very much. You're awesome.